Hello friends, welcome back. In the last part we covered division of numbers where divisor is not so close to power of 10 using transpose and apply technique. In this part we will apply the same technique to equations of any order and see. So let's start. So here is the first example where we have to divide a quadratic with a simple equation. So we write down the divisor as we normally do and then the dividend. Below the divisor, ignore the highest power, and for the next coefficient, change the sign and write it down. And then we do the normal multiplication as we have learned in the previous parts. So now 12 times 2 gives us 24. So write it down below the next coefficient, next power of x. And then 24 minus 3 gives us 21. 21 times 2, 42. So write it down below the next number till you have reached the rightmost number. Then once you have exhausted this, then you just write down first of all coefficients, and 42 minus 2 gives us 40, and then you write the appropriate power of x which you will receive after the division. So it would be 1 less than the power of the divisor, so it would be like x square is the highest power of dividend, and divisors is 1, x raised power 1, so it would be just x, and then plus 21, and then 40 is the remainder. So answer in this case is 12x plus 21, and 40 is the remainder. Let's look at another example. In here again we do the same thing. We write down the divisor like we normally do, and then the equation that we have in question, and then you write down with the change sign, and then do the multiplication. So 7 times 1 gives us plus 7, and 7 plus 5 gives us 12. So into 1, 12, and then we write down the result. So first of all coefficients, so 7, 12, and then the remainder is 15, and then write down the appropriate power of x, so it would be 7x plus 12 and 15. So answer in this case is 7x plus 2 is quotient and 15 is remainder. Let's look at another example. So here our power of our highest power dividend, if you have noticed, is increasing. So we write down the divisor, then write down with the change sign the numbers, then you start multiplying. So 3 times 1 gives us, so let's say plus 3, then 3 minus 1 gives us 2, 2 times 3 gives us plus 6, 7 plus 6, 13, 13 times 3 gives us plus 39, and then we write down first of all the coefficients. That's 1, that's 2, that's 13, and that's 42, and then we write down the power of x. So for the first one it would be x square, for the second one it's x, and then plus 13, so there's a quotient, and 42 is the remainder. Let's look at another example. Here power of highest power dividend is even going higher, so again the same principle will apply. 6 minus 4 is our divisor, then the dividend, and then we write it down with the change sign, and then the multiplying. 4 times 1 gives us 4, 4 minus 3 gives us 1, into 4 gives us another 4, then 4 plus 11, 4 plus 7 gives us 11, 11 times 4 gives us 42, 44, and then 44 plus 5, 49, into 4 gives us 196. And then we write down the coefficients first of all, as we do. 1, then minus 3 plus 4, another 1, and then 7 plus 4, 11, then it's 49, and then it's 203. And then we adjust the powers now, because again the same thing, highest power is x4, highest power divisor is x, so the first power of the quotient would be x cube. So that's our first, then plus 1, and then the next power would be x squared, then plus x, then plus 49. So that's our quotient, and the remainder is 203. Now so far what we have covered are the scenarios where the highest power divisor is 1. What if it is higher than 1? Let's look at that example. So here if we go, so in here you can see there are two things to notice here. One, that the highest power divisor, as I said, is higher than 1, and then there are few powers which are missing. For example, in the dividend, if you see, we see power 4, 3, but then the square is missing, so we need to have that as well. And similarly in the divisor, power 2 is there, but power 1 is not there, so that we need to also adjust. So the first step is write down with all the powers included. So that's our divisor, and our dividend would be like this. So in here you see we have added the power for both the missing terms here in the divisor as well as in dividend. Next step, write down these numbers with their change coefficient. For 0 it doesn't matter, and for this it would be minus 1, and then do the multiplication. Now in the multiplication the technique is, okay, first step, do the multiplication as usually we do. So it would be 2 times 0 gives us 0. Now for the second term, you do the multiplication of this highest power coefficient with the last term of the divisors. So 2 times minus 1 gives us minus 2. Now we exhausted basically all the multiplication, but still we have not exhausted all the terms in the dividend. So we need to do the second step, multiplication as well. But in this time we would not be multiplying with the highest power, but with the second number from the left. So in this case it would be minus 3 plus 0, that gives us minus 3 to multiply with, and again do the multiplication with both these numbers. So minus 3 times 0, so minus 3 times 0 gives us 0, and then minus 3 times 1, minus 1 gives us 3. So it's plus 3. Still we have not reached the right side limit, so now we need to multiply with the third term of dividend from the left side, which would be 0 minus 2 plus 0, again minus 2, and now we need to multiply minus 2 with these numbers of divisor. So minus 2 times 0 gives us 0, and then minus 2 times minus 1 gives us plus 2. So now we reach the right side term of the dividend. So now we can write down coefficients for quotient and remainder. So if we start from the highest power, it's 2, then it's minus 3, then it's minus 2, then it's 0, and then it's another 0. And then now let's adjust for the coefficients of x. Now in this case, if you see, the highest power of dividend is 4 and our divisor is 2. So the highest power we can have in quotient would be x raised power 2. So if we write down power 2, so that's our first term of the quotient. Then it would be x, and then the minus 2. And remainder is all, if you see, 0 plus 0. So remainder is 0. So in this video, what you have seen are the number of scenarios where you have to divide equations of any order, again with divisor of any order. In the next part, we will look at the general formula for division, which will apply to all kind of equations. So for the time being, practice and practice, and see you soon in next video. Bye for now.